create the geometry for that. Let's say procedure Lego. Okay. And go inside and pig head here. And you can see, boom. Let's make this size a little bit bigger, like three times bigger. Okay. 3 times bigger here. 2. And I'm going to explain a lot of stuff. Even have you learned that all the like vector addition and subtract, cross product and dot product kind of stuff? Have you guys learned that?
In like coding? Like
It's not really coding, it's a kind of simple mathematics in VEX. Not yet?
I did on my free time, but I don't think we went over it.
All right. Okay. This is very important concept to understand that if you guys learn that variable lighting, CFX, FX, then you have to understand that vector addition and subtract kind of stuff. So I will explain that a little bit here. Okay. There's a add. Let's do the add here. And create the point here. Boom. This one is going to be in the center. How can you make this one a little bit bigger? Just press D key. And let's show that the geometry visualize point like to point size like a bigger, like 10 something. Then you can see the point here. Okay. What is the point means? This point is just point, 1 point. What information in there? See, we see the position data, 3 vector data, right? So if you change this one to 1, it means this one is gonna be changed. So that means here, where is it? There's no point here because this one is moved to Y direction like this, okay? Just from 0 to there. So how can you change this point in Wrangler? Have we tried that before? Point Wrangler. Add that. I'm going to use Wrangler a lot. So need to understand that what I'm doing here. The Wrangler here, I want to move this point Wrangler to change this somewhere. Okay. So if the point Wrangler means the P, what is P means? It's the position, right? If you put that position, how many the data we need that for position? The 3 data, X, Y, Z, right? But if you put that 0 means it's 0, 0, 0. Then boom, it's going back to 0, right? This some position going back to 0, 0, 0. Which means we ignore this data, right? That's already that was what 0, 1, 0. What do they say? Ignore the data. Just replace this means because this equal means assign, right? If you want to keep that previous data, how can you do that? Previous data with the plus or minus. How can you do that? Just simply you can do the plus like this. Sometime I want to keep the previous data plus 0 means we can keep that previous data here, right? But if you want to, I want to keep this data with the x-axis to move something. Set 1, 0, 0 means what happened? It's gonna move x data here like this position like this, moving like that. Okay. Can you guys get it? If you say something, then that could be really helpful. Okay. Because sometimes if you don't answer that, I'm going to keep moving really fast then without your understanding sometimes. So how I want to move this one. How can we do that? I want to move to the x-axis, keep based on time.
Do $F.
Yeah, that's $, put in Vex, add frame. Okay, so this is gonna be moving, every frame is moving to boom. Oh, that's really fast, right? Oh, that's every frame is gonna move each frame like this. But if you want to make that shorter, how can you do that?
Divide it.
Yeah, divide it or multiply with some smaller point, right? Here, maybe you can do that here, 0.5 or 0.2, something like that. Boom. It's gonna be slow, right? Boom. Oh, what about if you want to make some kind of wave pattern up and down, how can you do that? Maybe y-axis is gonna change that, right? I wanna put that this y-axis here. Or I want to put that this one from the center without any previous. I'm going to ignore that previous position here and moving it. I want to move up and down, moving up and down. How can you do that? Maybe we do that sine function here, okay? And same thing, frame, right? And let's see, up and down. Oh, that's moving like this, right? That's the up and down and moving like this. Oh, that's too many. If you wanna make that the happening like this, just little bit longer wave. Now it's really shorter stuff. How can you do that?
Multiply the sign.
Yeah, multiply the sign. Yeah, that's great. 2 times, right? Then oh, still the same. Only the up and down is higher than before. This is we call the amplitude. Okay. So how can you make the little bit longer distance with this one? Maybe this one should be, but the frequency need to be reduced to 0.5 something. Let's do that. Which means this is a little bit longer, right? Maybe 0.1. It's much longer. Wow. Okay. Boom. Yeah. But if you want to do that, if we wanted to make that a little bit only no negative value over y-axis. How can you do that? We can do, oh, if there is some negative value, we just change it to the plus. That's the absolute function we call ABS, okay? Then everything will be positive, which means here, boom, bum, 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 okay? Like we did here, if you do the amplitude a little bit higher, then you can see bum, 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 like this, okay? This is like a procedural animation we can make it a little bit. Also, you can do that. Oh, I want to make that this higher and slowly smaller. How can you do that?
Multiply negative frame. Something.
Negative frame. This is like we did that. This is height means amplitude, right?
Yeah.
So now we need to think about the tool. How to make tool first. Okay. Think about that. This is really hard to read that. Okay, so let's do like time. Okay, plot. Maybe speed. How can we speed? Let's do that speed. Okay, which is like this. Copy with this guy. Speed like a x. Okay, let's do the speed x. Is this okay? Another one is speed y or something. Plot speed x. Okay, this is speed x. Just change that this one to here to there. Okay, this is x-axis already, we made that. But another one is we do y, okay? Plot speed y. Means we do copy this guy, you need to copy. Paste it. And speed y. Here. Which means really clean, now is clean the result we can see. Only we can change that this area, right? But like I said, that's a frequency. Can you read that properly? Frequency of the up and down stuff or the speed x or whatever. Okay, so let's do amplitude. Plot AMP channel like AMP. Okay, then when you create the channel stuff, boom, that will be, this one will be appear, and put that this guy here, and this is the amplitude. Okay, if you do that, if you change that this number, then you can make it. Boom. Okay, but if you want to make that this what is this? This is frequency, right? So let's do the frequency here. Plot frequency of this channel. Frequency. And create another one. That if you do that it will smaller one, then you can do that and copy this frequency. That's easy, right? So then here, boom. If you make that a little bit faster, then you can do the faster, smaller. Okay. Can you guys follow?
Yeah.
There is a two-way to reduce this amplitude. How can you do that? Maybe you can do the keyframe here, right? You can keyframe here, or if you wanna do some frequency, like reduce your based on time, how can you do that? Maybe your amplitude is here, multiply. Maybe let's say decay, plot decay. Okay, which means you can put the number. Do you know that fit function here? What is fit function means? Okay, that's very important function here. Fit function is like oops. Oh, okay, let's scale. Sorry. Fit function is like this. Here, data is there. Okay, let's say any value here. This is a 4, 2, 7. Okay, but I want to remapping the value of this like whatever number, 0, 1, or maybe 2, 4, whatever number if we want to do that. We need to do this. Okay, we need to use a fit function. Just simply, there's a lot complicated one, we can do that. So fit whatever value, something here, then something whatever number value here. But this is old. Okay, old means original. Old minimum, maximum. This is new, minimum, maximum. So let's do it. Here, the fit function is here. We need value. I'm going to use a time, okay, or a frame. if the frame is start from 1 to like 100, okay? I want to fit that start from frame 1 to 100, okay? I want to start from 1, okay? Frame 1 is 1, but when the frame is 100, then 0, okay? 0. What does it mean? When it start frame 1, this value will be 1. The frame 100 means 0. Can you get it? Right. So we can multiply this decay onto this amplitude. Can you get it? The everything? So what happens now? It's gonna be slowly decay going down, right? Oh, that's the procedural bouncing ball already done it.
Right.
That's easier, right? So which means that we can make the rate be higher and everything, but still slowly we can make that, and also frequency a little bit lower or whatever. Okay. Any question?
Yeah, so for the fit, you have to write like a float first and then the value of that float.
Yeah, value of the float. If
Right.
that is the value of the integer, then you need to put the
Yeah,
integer
what happens if it goes over?
over number.
Yeah, if I don't know if it's frame, hold on, let me try it. Frame 120.
120, you can do the 120, which means when this value is 120, it will be 0.
Okay.
Okay.
Yeah. Wonderful.
All right. Okay. So you guys know that all the float, whatever, what about this one? App frequency. What is the difference? This is have you guys learned that the wrangle stuff? What is the difference between this one and float, just like that? This is same thing, right? Frequency is the same. But when you put that, this one is no error here. But this is same the function we have, but the y is not error here. And what is the difference between two? Okay.
Is it?
Yeah. So
Oh, so one of them, yeah, I get it.
yeah. One is without app means that before there's a frequency value is there. Frequency is there, but when you see that, nothing is happening. When you put that frequency, then you can see the frequency number here. That's different. Oh, but frequency is supposed to be this number, but this one is the same, but before we assign the value, there's nothing is happening. Only we can use this function only this node. But if you want to use that, this app means you can inherit this value to the next node as well. So that's very different, okay? I hope you understand this part.
Yeah.
All right. Okay, get it? So this is how we can make some procedural animation with this one. Really simple idea, and I will explain that later a little bit different the mathematical function later on. And this is concept of the procedural animation. Okay, and later we're gonna use these techniques for some procedural animation with this peak stuff. Right? Okay, let's move on. All right. Okay, then let's move this one to match size. Have you used a match size?
Yeah.
Okay, cool. Let's bring it. And this one is going to be always the center here. But I want to change this y-axis to the minimum here. Then we can do that setting here. Okay. Cool. And let's do here for volume wrangle, volume point volume. And you can see, oh, there's a lot of stuff. Let's make this guy like a 4. Oh, this point is now way too big to see it, right? So let's make this one to the original size here. And you can see this guy here. This each point we're gonna have it. And what else we can do that? Let's see, let's show them here. Let's make that another modeling. This is in the SideFX basic tutorial, you can see that here. We're gonna use the copy function here. Box, no, oh. Let's create the box, right? And the copy function to copy the point here. You want to do that, then you can see that this kind of, creating, we can see that. But the problem is this one here. This is exactly, that's a lot of overlapping issues here, right? That's overlapping each other, which is we don't want. Okay. So first, this box. Let's create the box here, and let's do the size of this. This one is the just exact number 0.2 first. 0.2. 0.2. Okay. And also, I want to divide that this one in 3. Okay. 3. This is what I want to make it. The another one is poly extrude. You do the poly extrude to area. Area to really build this down here. What I'm gonna do here is select this 4 and tap poly extrude. And let's make this one insert like a little bit down here, 0.04. Okay. And some edit. Let's do some addition. Edit number here. Okay, let's do some edit here. Then we can change this to the point and select this guy. This 4. Okay. And just make a scale here and just reduce down like this guy. Let's make this guy 7 here. Yeah, then you can see you can make that this small. And select another primitive here to select this 4. 1, 2, 3, 4. Okay. Another poly extrude.
How do you do the points again?
Point, you can select this to the point like this and select the area. Okay, can I show you that again?
Yeah, please.
Okay, so add it here before we do that. And go to the deselect and go to select like this and select this corner of that. Okay, and tap. It's no need to tap, just select the scale node, then automatically will create the edit node. Make a smaller size here, like 0.777. Okay. And go back to primitives and the select again. Only extrude. Just up like this and 0.05 here. This is a label, right? So another one is the you can select this back here, fully extrude again. fully extrude again, and 0.025. Just make that like this. Same thing. Same thing, we can do the fully extrude from here, another fully extrude here. Fully extrude, another one, then moving up like this. Shoot. This one maybe 175. And now we can see that this guy is like this, right? All good? Right. Okay, just follow that up to here. Just think about that. Just simply, you guys can select that area. Let's take time a little bit. Oh. That's not matching, right?
No, that's
Yeah, that's the
Like
thing.
playing.
Always that is another challenging stuff to matching properly, exactly matching it properly. All right. Okay, let's keep moving. Okay. This is a recording. I can show that really crucial stuff here. And here, and we need to make some group of this. Before we do that, let's do the polybabel. Polybabel here. What is a polybabel means? Then here, if you do that, disconnect them, and maybe do this on like a like this, right? Then let's do the 0.206, something like that. And maybe you can make a little bit more, 3 then. Then you can see that this is something like this, right? But the problem is this. If you do that just smooth, then you can see, can you feel that this area is still,
yeah.
the square, right? We want to make some really circle around here, right? So that's not going to work. So we need to only select edge area like this top area, so this bound area, maybe this area a little bit, right? So how can you do that? We need to make some groups with edges here, only outline. Okay. So before we bevel here, group, let's do the group in there. And this change this to the edges. And let's make this edge something like that. And turn off this and include by edges. Select this guy. So nothing is going to happen now, but let's do the unshared edge here. Select and the minimum angle stuff here. And select this guy here. Oops, that's the lot, and just move it. Oh yeah, this change that, and you can see, select those area, outline here. That's what I want. Okay, this is the edge group. Let's do the 50 something. Yeah, still okay. Okay. This is group that we want to smooth them, which is polybabel. So select this guy, everything there, but we do select on the edge like this, then we can see only this area. Right? This is what I want. Then when you do the smooth level, then you can see the smooth here. I think it is group here. Then go to this group. and change that this to the edges here, and enable this include by edges, change that this minimum edge angle 50. You change that how much that, but you need to check unshared edge down there. Then you can see, and after that, if you don't see that the edge groups here, just select choose handle here. Then you can see the handle of the group. Yeah, then apply that. This is the only thing you can see. Just don't worry about that. This is kind of smooth already. Apply. Okay, everything is okay, fine now?
Yeah.
Okay, good. Then let's connect this guy to the copy node. Here what we have, copy node to there. Boom. Just select this guy. Oh, now we have this something. Kind of, oh, that's the one that, but what happened here? Size is not really correct, right? Why is that happening?
Looks like separation.
Yeah, that's the thing. Different separation is still, but we need to still to have you guys used the copy swap to change the scale? Okay, change the scale means here that's we call the point triangle to use it. Let's say this one is the P scale, okay? And let's make that this one like a P scale like a 0.4. Oh, that's make it this one smaller. Let's make this one 1. Oh, if you do that P scale 2, oh, that's exactly matching now, right?
I think that's just P scale.
Yeah. If you change the P scale, then it's gonna matching, right?
Yeah.
So I will give you some idea here. Can you guys bring this color to this color? I mean, this color. Can you guys bring this color to the point here? Can we? How can we do that?
Looking there.
That's actually this is kind of display. Without display, it's nothing, right? But here display can show that, but we don't see that without display, right? But without display, still want to see the color here. So it means we need to bring this color attribute from the texture, right? So when you go inside, there's a shop here, the peak. The texture is there. Oh, you can see that this texture, copy this data, copy parameter. Okay. Then attribute map. From map here. And paste this channel here. Then we can bring the color, right?
Where do you find the color?
Color here, then go inside, go to the peak and shop net. Peak, there's a texture. Right click, copy parameter here. Then paste this, then we can get the color data, which means we can store this color attribute from the texture. You can use attribute from map. And we can apply this data to attribute transfer to here to the point. Then now we have, right? All right. It's fun? Yeah. All right, let's do that. Here, now we know that how to change the P scale here. When you put that P scale, then we can get the proper one. But what if I want to change that this one like a 3? It's more, which means more point. But the problem is here. Oh, what happened? It's some overlapping each other because this is a less means that more point, right? More point means that you have to change that this guy is a little bit smaller. Or how can you make that? This one is smaller, right? 1.5 or something. I'm not sure. You get the same, or this is not way. This is not a way with the procedural modeling, right? We don't do that. This manual stuff. So we have to make something, some kind of a way to calculating something, right? Based on this number, we have to kind of change the function here. Just copy this parameter here and the paste relative same thing. Then we can see that this number, right? And the p scale. Let's change that this p scale to this. Okay. Let's see what happened here. Okay, this is p scale should be right. This number should be 1 always. Okay, this number should be always 1. But basically, we start with this scale is like a 0.2. Okay, so here, let's do that. We do the fit function, but there's a e fit function. That's gonna be a little bit different. The 0.2. 0, start from 0 and 0.2. This is old minimum, old maximum, and should be 0, 1. So what happened here? This one is gonna be always matching. E fit means that even if that number is bigger than 0.2, also will matching them. It's whatever number is fine. So here, this number is 3, but even if that's a 2, still it's gonna matching based on this. Okay? 3 is matching the size of this. 4 is less point. Still, you're gonna matching. So this is very important. So this is if fit function. You need to searching them what it is. Okay. Copy the parameterize copy parameter and right click paste to relative reference. After that, you put that the function, because after you paste relative reference, you will replace everything. So after that, you do here.
So what's the EFIT doing?
This is homework, okay? To such that you have to understand that what's the different fit and EFIT. Find some Googling with this one or ChatGPT, asking the ChatGPT what is the difference with the fit and EFIT. Still don't understand that? Or
is EFIT like the opposite of fit, kind of?
it's not really opposite. You know that that's the old maximum, old minimum, right? Old minimum, old maximum is there.
Yeah.
But what if the number is over the old maximum or old minimum? Which means 0.2 is the kind of, if this is 0.4 or 5 something, then it's not really, which means just a fit. If you just use a fit, this number is 0.5, which means that is still they just fit. There's no more 0.4, 0.5. So they always make that, oh, this is 0.2, everything is 0.2. So this is really hard to explain that. Here, just graph is this one. Okay, fit function is always like this. This is 0.2.
Okay.
Right? So everything is okay. This is the new fit is over the 0.2. Even if there's a 0.4, still they fit that this one like this lamp here. But if they're gonna make that this one like this. Even if there's old maximum is here, 0.4, they will oh, there's over number that we just let's make a new fit here. Edit fit here. Whatever edit fit here is. It's kind of that sort of relative fit. If there's number is higher, oh, we have to refit this guy bigger than that. We always matching this number. Any number of the maximum, then we can change that.
Okay, that makes sense.
Yes, it's kind of you can feel that what it is, and that's the difference between if it and a fit. When you fit it, then bigger than this number, then it's not gonna work. You need to do that if it
Yeah. So if we fit, it works from 0 to 0.2.
only there. Let's do that. If you do that, this one, yeah, it's not working anymore.
Okay.
If that number is higher, smaller 0.1, it's gonna work maybe.
Just takes a minute.
Oh,
Okay, that makes sense.
yeah, it's really higher, right? But that 2 is fine, but the 3 of the 3 is not gonna work. But you do that if it, then
Okay.
it's gonna work. Mhm. This is what happened here? Always
So basically, the normal fit is taking, so it is saying it's taking this value and seeing it from 0 to 0.2, and then giving a value from 0 to 1.
yes, numbers.
That makes sense. Yeah. So basically what if if it goes over 0.2, so here it's 0.32, so it's over. Fit is just gonna clamp it back down to 0.2. EFIT is gonna like make a new maximum value. I can try to explain it later. It's
No, that helped.
yeah.
Alright,
You get it?
Yeah.
You can visualize it if you make like an FPD out of it.
Right here. Great. All good?
Yeah.
Okay, I want to make that now same thing. Same number here. And what is it? Love toy. Love toy. Yeah. Boom. Okay. Exactly same. Just copy that. Okay. Paste it. Oops. Then paste it. And change that this two, change that this two. Only difference is this guy. Just go inside. And it's another one. Texture here. Right click, copy, and paste it. Paste the relative. And let's get this guy. And boom, like this. Okay. And you can see it. That's different. Oh, that's a smaller one. So I want to make that so a little bit small like this. Let's see. Oh, what's the difference here? We need to change that. This is volume wrangler point separation here. What's going on? Oh, still not a good number. Oh, okay. Need to unpack. Unpack here. Oh no, this is fine. What's going on here? Oh, okay. Got it. It's too small. Let's make this one 3. Okay, and also
Did you have to redo the color?
redo the color and just point size like 2. Yeah, oh, that's a really big number still. Now you got it, and then you can see it. Oh, I don't like this kind of attribute here. Because there's a normal path is there. So only just copy that the color only. Okay. This one is also copied only color only. Otherwise you can get the the normal value here. Copy this. Same thing. You do this. Okay. There's two stuff here. One is this. What is that? If you go to the SideFX website, you can see that this kind of techniques, but there's no procedure, the separation techniques there.
Yeah.
So because he didn't explain that, because when you change the scale or number, it's not matching each other. But this is a way you fix that stuff. And I'm going to explain that the copies of more. I think you guys don't understand how copy swap is working. No, before you do that I will show you here. Just have a look at that. Yeah, before we point connection here, something is happening like this. Why this one is happening? Can you understand that? Why?
Do the points have like a direction to pointing to?
Yes. Why this one is happening? With only we do that color, that was not working. That was working like this, what we want.
Yeah.
But without this, what attribute transfer is doing?
Capturing all the point attributes.
Yes, that's from right side to left. Every attribute is transfer. But we point that out only color. That means we transfer only the color attribute. But why other attribute makes this the orientation value is changing? Because this copies of read that when you copy node based on the point attribute of the orientation value, make that this rotation value change, which means, but what if there's no orient attribute? Oh, okay, they can read the normal attribute. What if there's no normal attribute? They can read the velocity attribute. That's the order number, okay? Priority is orient attribute. Second one is normal or velocity, I'm not sure. Third one is velocity, something like that. So why this one is important? Because that is the matrix. This is most important part of when you understand that the kind of matrix in Houdini is very, very important. So you need to really understand this part. So why this one is really important? Because when you create some velocity from the body or whatever, or if you want to make some building procedurally, always you need to use this technique. So, okay. Anyway, I will explain them more about that. Here, this is a peak here. This one is the stop. So I want to break this guy. I want to make some RBD simulation on that. How can you do that? RBD simulation, have you done it before? Okay. We need to make this guy, maybe you guys use the RBD solver or something like this.
Yeah,
this one? Okay, let's do that. Let's make this one here assemble first. Okay. Assemble with here, and let's make this guy as a piece at P. Okay. And also create the pack primitives, which means this one as if, the before here, middle click, there's a lot of polygons here, but the assemble with pack, then we can see the number only. Can you see that? This number is actually same number as this number, pack number, point number is same number as this point number. See? Okay. So which means this pack primitives as if this one is point. But one different thing is this point and this point. This is only the point, right? Also, this one is point. Looks like point. Even if we see that this cube, still this one is point. Something like add here. And to click that, this is like point, right? Then we can see the point as well. what is the different point like this one, and this point? This one has intrinsic data. Have you heard that before? Okay. So here, this is looks like a point, but when you go to the primitive, there's intrinsic attribute here is hiding. Then we can see all the transform value here, which means let's see this transform. Oh, that's the data here. Something like that. This is we call the matrix. This is a rotation data is in there. So whenever you want to change that rotation value of this matrix, this pack primitives, we need to change this matrix data, which is a little bit seems like really complicated because number is too many. But I will explain that later more of this. When you understand this part, it's gonna be really easier later on. So this is a pack. Anyway, we have a point with the intrinsic data, which is we call that this. That's a difference between just point and the pack primitives. Okay, this is refer from the data is somewhere around, and but we represent it as a just point, but there's a matrix data in there. So another one is the here. Just copy this to here. Let's say this is let's say this is maybe any I don't know toy, and the same thing. This is 3,000 something. Number is a little bit different, but here this one pig and here. So first of all, here we do RBD solver. Let's start from here, go there, and then let's make some ground here, ground plane here. The play, boom. Yay. Make this one. This is too slow. I wanna make it a little bit lighter, like a 4. Okay. And play this. Okay. Have you built your own RBD solver stuff before?
Not from scratch, no. We
Not from
this.
But what I'm doing is I'm gonna do that from the scratch, okay? That's what we need to understand that part. Okay, so this RBD solver, just go to the right click, allow edit of contents. Okay, then when you go inside, wow, this is a solver that they made it. They are crazy, you know.
Yeah.
Everything is there. And when you go there, oh, there's a DOM.NET is there. Oh, there's a solver is there, right? This is a blast solver and everything. Everything is in here. That's why you guys really easy to use it. But you know, sometime I don't use this one any still. It's really complicated to me, and it's not really it's hard to control. Maybe I'm really old school. So, but we have to understand that under the hood here what it is, right? So what I'm gonna do here, create a null here, put that this one. Let's say this one is um source RBD source. Okay, let's say this and create a thumbnail, which is there is inside this thumbnail same as that. Okay, and let's bring that this same thing top import here. Let's bring it top import here. and just going that, okay? Drag and drop. And we select only one object, but inside there's nothing here, okay? We do have pack, okay? Pack object. Let's do the pack object. Let's see, this one is RBD.
Can you go back just a second?
Mm-hmm.
So document.
From that here? Just drag and drop here to there.
That's.
And go inside. Just RBD path object. Just create that. Another one is just flash server. Okay. Another one is the ground. Another one is the gravity. Okay. That's basically what we need. Okay. Another one is merge them together. Is the left is ground, right is here, and just select that. Then we bring that first input of this. And then we see it's exactly the same thing. Exactly the same thing what we just did. Okay. If everything is working, I will give you some time to make that work. Okay, then can you do that? I want to active from top to down or left to the right side. Active, like, I want to active from the right to the left.
Like a wind or something?
No, active, just static, but the start from falling down left to the right.
Oh,
Right to the left.
right.
Well, from the center to the outside to the inside. Oh, right.
Yeah.
That's okay. So you need to run, right?
Yeah.
What if the moving character or working character is there and slowly falling down? This is basically same techniques as disintegration stuff.
Yeah, like a clip.
Yeah, that's something. What is it? Probably it just bridges there. Bridges the tracking from the top to down. So, well, that's all the related technique. Yeah. Let's try that. How can you do that?
Looking at my notes.
No, I will maybe I can bring one of my assistant. He's also he just working for that's a really hit Sony show, and that's an animated show in Netflix. K-pop.
Oh, yeah,
K-pop. Yeah, he was working on that as an FS artist. I'm gonna bring you
really
guys
cool.
on with a bit sometime.
Yeah.
When I'm like here or like he's really good. It's all good. Everything's working now. It's working. Okay. Let's make some initial velocity of this. Okay. How can we do the initial velocity? Initial velocity here, which means here, this is as if this one looks like a point, right? This is same as point. So we can apply the velocity on that. So here, point velocity here. Apply this. I want to visualize this one here for add node here to there. And just delete the geometry, then we can see the visualization on that, this one. And I want to see the velocity of the visualize properly. So press D and go to the visualization and select the marker and the V, and the vector. Okay. And we can see the velocity of this. So can you see the velocity here? Nothing, right? The V, marker, vector, V. Just change this style like a vector. Very good? Yeah. Why we need that, this one for? Because we need to visualize visually, we need to check that out. But nothing is there. So the point velocity is nothing happening here. But when you put that this one add here, then you can see oh, that's up, right? This is up. And maybe you can apply the central noise click, then oh, that's something is happening. Then like this, then you can see. Maybe, oh, I want to add the call noise here. Then, oh, there's something is happening again. Without this, something like this. Oh, what happened? Okay, here. So here, anything if you want, just source size a little bit, scale a little bit bigger, source size a little bit bigger like this. I want to make that a little bit bigger source size here. And, oh, I like this, okay? Then after that, oh, visualize and everything, I can see that, oh, this is velocity is going to happen. Then turn off this add node and turn off this stuff and add node as well. Otherwise, you don't see that much. And go inside and go to the RBD. Just inherit the velocity from the object, okay? And let's see what happened. Boom. Oh, there's something is happening there, right? I feel like a little bit there, but I think it's not enough. Yeah? So here, there's a velocity there, but it's not enough power. So now here, very important concept of the velocity. Actually, I have a question for you. What is the velocity? That's the question. Speed? Yes. Any? Hey, ladies and boy, what is the velocity? Velocity. Velocity. That's the velocity. You guys heard that so many times in your high school. Yeah. So in Houdini, let's say velocity is you can search the Google the what is the velocity means. But in Houdini, let's say the power multiply the direction. Okay, that's we call the velocity. Or what is magnitude? Okay, magnitude multiply and direction. That's the velocity we call that. What does that mean? Here, this is very important. Always you need to keep that in mind. The velocity has some direction here. Okay? But it's not important where this start. Okay? Start from here, it doesn't matter. Always need important thing is the length of the velocity. Okay? Length of velocity or direction of velocity is very important. If the velocity is longer like this is gonna be really higher magnitude of this direction, right? That's the thing. So, but why I'm saying that this is this two values there? Let me show you something. I have to explain that properly. I'm trying this to explain that really easily. Always I'm trying. I have to, but this is very important. Okay, this is not only velocity thing. All the vector function is always happening there. Let's going back to add node here. The beginning of this here. Create this here. So we have point triangle here. Okay. Now let's say this is a velocity. Set to 0.1.0. Okay. And select this guy. Oh, now we see this one, right? 5 like this. Oh, that's a too long. Okay, like 2. Okay, now I wanna ask you, what is the length of this from here to there?
It's 5 squared plus 2 squared.
Oh, okay. That's you guys learned that the trigonometry in the high school, right?
Yeah.
Boom, 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 boom here.
Yeah.
Maybe we can calculate that this stuff A, B, C. Guys, remember that this formula? What is the official formula name of this?
Gosh.
Huh?
Can't remember this. I got
Right.
it.
So okay, that's in maybe thankfully, you know that Houdini or the 3D software has some calculator in the calculate as a function.
Pythagoras.
Pythagoras, right? But in Houdini, there's a way we can measure them. Really simply, you can measure them. Okay, we call that the two things: length or distance with the 2 point. But there's only 1 point, so length of velocity. That's all. And here, let's say this is the length of velocity we call magnitude. Oh, this is let's say this is power. Okay, this length is power. Okay, this length is power. What about the direction? Direction is only one. Only we need the direction, right? Direction means the 3 x, y, z direction only. We don't need to make that like this kind of number. Only we need the only unit number 1, right? This is from here to there, so unit number 1. Only we need the direction means only total length of the vector is unit is 1, which we call the normalize. Okay, so here vector direction, here normalize vector here velocity. So that means this direction is the let's see here, maker director direction, ERI with the vector. Then let's see that this is a kind of red here. Okay, can you see the red color here?
Yeah.
So this is a normalized vector. Okay. So what did I say that? So this velocity or vector, I said the velocity, right? But the velocity is in computer graphics is a vector number. Vector is like a vector is some kind of it's not not programming. Vector is some kind of a direction. We can see the arrow. That is like we applied this velocity like 0 means nothing is happening, right? But but if you do that, what I said that direct multiply magnitude, right? Then you can see exactly the same number of what we have, right? Why this one is important? Why do I have to learn this one? Because vector addition always makes you guys headache. Oh, I wanna add that. I wanna change that this one to direction like this. Okay, this direction here. I wanna change that this direction, but I wanna keep the power when you change the direction here. Oh, I wanna do that. If you do this, for example, here, there's a vector is there, plus get set. That's okay. That's y direction, right? 0.1, 0.0, something like this. I move this one. Oh, still there. Well, let's do the 10. Oh, still there. 5. Oh, we don't know that. 10.